2.5, this page before, I just added it in front. We're going to talk about the difference quotient, which is kind of a method that we're going to use. So far in skip back to 2.2, we have a preceding and following. So this was us finding the preceding slope. The following slope is after it. So this was the following and the preceding. What we did is we took those two numbers, we added them and divided by 2 to get the average of the preceding and following. So that was one method. And then this next method that we had was the centered interval. The next method we had, so this is the adding the preceding, following, dividing by 2, right? The average of the two. The next method we looked at was a centered interval, which meant we just took 2 points beside, right, around it, and divided it by the difference between. So y2 minus y1, same thing. Okay, so that's the centered interval. So those are the two methods we had. And then here at the bottom of the page, I said, well, we started to look at what happens if I develop a formula for this, right? So with this formula, what we had is that we said this one here, that's like your Q, and this is like your P. So we're finding the difference between the P and the Q over, and then this difference here, the way that we got this H, so let me just point this out, it's x2 minus x1, correct? But why did I only put the H? Because x2 is a plus h, right, the little bit of a difference, and x1 is a. What's a plus h minus a? Just h. So that's like saying if Q was at 3.01 and P here was at 3, so we're looking back at the same point, right? So just talking about the investigation we did last section. So 3, 9. If P was at 3.01, Q was at 3.01 and P was at 3, what's the difference between 3.01 and 3.01? So that's the difference. So they already subtracted it and got the H on the bottom. So the formula, everyone's always like, what happened to x2 minus x1? They subtracted it already and just put the difference. So H is the difference. H is the difference between the P and the Q. And we've done preceding and following. So H could be before, H could be after, but that's where they started with this formula. So what we're going to do today is we're going to look at using this formula for a little bit of it and then using the difference again. Okay, so right here, so that's our starting point for today. So last day we looked at preceding, following, centered. Now we're going to look at this, and we're going to call it the difference quotient. So the difference quotient means division, right? So difference quotient is this. So when we say difference quotient, we mean this formula here. So one more time, the top here, that is still y2 minus y1. Is that okay? Right, so still slope. Y2 would be like the Q point, at P at 3.01, that would be P at 3, right? And then on the bottom here, that's x2 minus x1, which is, right, which I showed on the other page, that is a plus h minus a, the difference between the two x's, which is why it gives me h. So that's why it's just h on the bottom, because they subtracted the difference and they just put the difference on the bottom. Does that make sense? So it's still y2 minus y1 over x2 minus x1, but for the x2 minus x1, they subtracted the a plus h and a, like the difference between 3.01 and 3, and they just put the difference on the bottom. Is that okay? Have we got the formula? All right, so y2 minus y1, x2 minus x1, they simplified it and put the h on the bottom. H is the difference. And we'll just write that again. H is the difference, so H is the difference. Difference. I can't spell difference. We're going to take that off. There you go. Okay, so H is the difference. Right there. Okay, so H, we're going to use a preceding, so subtract a little bit, and a following interval. So we'll do a little before and a little after. right? So same idea, but we're going to start with the formula. So our first step for this one is using the formula, and then we're going to average the two answers by dividing by 2. So it's the same idea of what we started with yesterday. Now, let's try it now. For this first one, I want you to just make sure that we write it on the left side of the page. Okay, left side of the page here, because we're going to do the algebra, we're going to do the difference quotient here, and then I'm going to sub the two h's, and then I'm going to divide by 2. So you want to start here on the left side, right? Don't start it right in the middle. Whenever I answer a question, I try to start it on the left side of the blank, so that way if I need to, I go to the right with columns. You never know how long a question is. So I'm going to start it here, right? Because sometimes people go, I ran out of room, that sort of thing. No running out of room. Start on the left and then try to do columns. And then you might run out of room, but at least you tried. Okay, so here, we're going to start with the difference quotient. So here, for my difference quotient, it's up to you. You can start with the general formula, or you can start with the 2. So 2 is my point that I want. Just like on the other investigation, it was at 0.39, right? So this one here, x is at 2. That means that for the basis of my formula, a is 2. Does that make sense? So a in the formula is going to be 2. Right? So I want f at 2 plus h. So if you want to on your formula, you can go right ahead and start with that. I don't need to see the a plus h. I can go f at 2 plus h minus f at 2 all over h. Right? So you can go ahead and plug that in if you want. If you want to, you can start one line above and you can put that down, this formula, and then this. Right? But if you want to save a little step, you can go right ahead and plug it in with the 2. That makes sense? Right, so you can still start with that if you want, but if not, start on this line. Then, okay, you want me to write the formula? I'll write it above. So if you wanted to, you could do f at a plus h minus f at a all over h, or you can skip that and then start here. So it's up to you. Start with this equals that, or just start at this line. Okay, now we're going to sub it in to whatever function I give you, right? And I can give you squared, I can give you cubic, I can give you square, I can give you any function. So we're just going to sub it in. The way that I make this line up is I always do my equals and I put my line, right? So I don't know how long it'll be, but I'll extend it. But that centers my question. Some people are like, how come yours seems neater than mine? Because you don't know where to put the equals. So I put equals and line. It centers your question, your equals on your line. Then we're going to plug in 2 plus h wherever I see the x, right? Our function notation, we know how to plug that in. So it'll be square root 2 plus h plus 4, right? So that's for the first one. I'm going to do the second one in blue. So minus, so this part here, and do that part in blue, f at 2. So this will be square root, put 2 in, 2 plus 4. Okay, extend this so it's longer. Okay, all over h. Let's simplify that. So this will be 6 plus h, or h plus 6, it doesn't matter the order there, minus root 6 all over h. Now, you'll notice that they do tend to match, right? In calculus, I keep mentioning it just because they're so intertwined, these courses. In calculus, what we do is we keep going with the algebra. They go, wait, is there a pattern? Can I do this? And we do lowest common, we do factoring, we do all the stuff we learned in grade 11. Lowest common denominator, factoring, rationalizing, numerators, denominators. We did all that in grade 11. We'll use those methods. For now, though, we stop here as far as we can simplify, and then we're going to use the preceding following idea. Okay, so what they did is they went, okay, and then I go here. They started to see that there was a pattern this way. And so in calculus, they continue with the pattern here. So for us, we're going to go as far as we can with simplifying it. You don't have to fully simplify. That's as far as I can go. Good enough. And then now I'm going to do the substitution. Okay, so if you're like, will I have to substitute decimals forever? No. Okay, eventually they went, oh, this is still frustrating me, too many decimals. And they went, can I algebraically simplify this more? And then they went with that. Right, so that's why. So this was we do this chapter, and then the next chapter usually we go, and let's continue this side and see if we can do this side better. For you guys, it'll be a 6-month wait, and then you will finish that side later. Okay, whatever, 5-6 months wait, right? So if you do take the calculus, if you don't, this is a good method. It's just it's frustrating because of the decimals. you'll be like, oh my gosh, so many decimals, so much punching into a calculator. And that's why they said there must be an algebraic way I can simplify it. But for us, we're going to do this. So we stop there. As far as you want to simplify, it doesn't have to be fully. I'll show you that in a minute. But that's good enough for me. It's a bit better. And then here. So what I want here is I want the title. We're going to say let h equal negative 0.01. Right? So the preceding. And we're going to let h equal 0.01, a following. Right? So we have preceding and following. We're going to put those guys in and find our m's. I am sorry, I have a typo here. I don't know why, but I'm going to try to fix this tonight if I can remember. 1 and 2, right? Because they're both h's. It should be a subscript 1 and 2. I don't know what I was thinking with that. So it should be a 1 and a 2 there, and then I'll do a 1 and a 2, because otherwise there's so many h's, right? It's very unprofessional of me. Then when I do my slope, I do m1. Right? Because then I don't have which slope do you mean? M1, M2, etc. So we're going to plug this in. Again, if you want to skip a little bit, you can. You can do this, 6 plus negative 0.01. But I always get someone who asks, can I skip that line? Yes. So the h on the bottom is negative 0.01. If you want to, you could have skipped to this line. And you could have gone 5.99 minus root 6. Like that. Okay, so when you do the decimals of that, oh, let me try to use the other first period cheat from there. So I plug that in. So H1, I got approximately, and I'm going to keep 4. So 4 decimal places is good. So let's try to keep 4 decimals until the end. And so that'll be 0.2042. Okay, and then this one here, M2, we've got the same thing. So you can skip this line. You can just put 6.01, right? I realize some people are like, can I just do that in my head? Yes. But if you want to show it, you can. 0.01 minus root 6 over 0.01. If you want to, you skip to this line, and you would go 6.01 minus 6. I don't need to see the little, I don't want to see, oh yeah, on your calculator, I don't want to see 0.599 square root, like, so 5 point, I don't want to see this. Oops, sorry. Please don't copy all that out, right? So don't do them separate and then show me a bunch of decimal places. Do the full top, right? I just subtracted it and divided it all at once, right? Try to minimize the number of times you have to copy out a gazillion decimal places. So I did root 599 minus, sorry, I know it's glare there. Okay, root 6, like that, and then right away I put divided by negative 0.01. So I did it all at once, and then I got 0.024, okay? So that's why. So I did this minus this divided by that. Sorry, I didn't show you on my calculator. I did it all at once. So one more time, I went square root 5.99 minus square root 6 equals, so I finished the top, and then I did divided by, delete negative 0.01, and I got that answer, right? So, and then I just wrote it down. So don't show me a ton of pain, okay? What a pain. So try to work with your calculator, and then just keep it there, and then just show me the answer, right? This is enough to show me what you subbed in, but other than that, I don't want to see, right? I don't want to calculate all that. So here, same thing. So you're going to go square root 6.01 minus square root 6 equals, and divided by 0.01. Like that. So I did it all in one go, and I got approximately 0.2040. Okay? And then for this one, my last step is to add them and divide by 2. So I'm going to go M1 plus M2 divided by 2, 0.2042 plus 0.2040 divided by 2, which gets me equals 0.2041. Okay, so if I ask you to estimate to 1 decimal place, I would still keep the 4 throughout the question and then round at the last step, right? So if I said to you, I only want 1 decimal place, you can round it at the very last step. In this case, I just left it because I didn't say what to round to, so I'll just keep the 4, right? But if I say to round, I mean keep decimals throughout and then round at the end. So round last step if asked for, right? Does that make sense? So if I ask you to round, don't do it until the very last step. Keep more than what I asked for, then it's more accurate. Right? So if I say round to 1 decimal place, don't round it off right here. Keep more, 4 is my suggestion, and then round it the last step to 1 decimal. Here I didn't ask for it, so I'm just going to leave the 4 decimals. Okay. The next one, let's try it again. So we're going to do the formula. So M equals F at, and remember this is A, right? So that's A is 1. Right, so we're going to go A, so it'll be 1 plus H minus F at 1 all over H. And you're going to plug this in. Now, the reason why I want to show you this is because you go, how far do you want me to simplify it? Not very much. So think about what we're going to be doing. Okay? So that's the first part, yes? I plugged in 1 plus H into the first part. Then I want minus, and I want this second part. So the second part I'm doing in blue here. So minus, let's extend this line. And you're plugging in 1 into here. So when you're plugging in 1 there, I need you to make sure you subtract the whole thing. So I do need a square bracket or a round bracket. So this will be negative, this will be 1 cubed plus 2, 1 squared minus 15. So this, right, this needs to be in a bracket like that. And this whole thing here is this part. If you want, okay, some people ask, if you want, you could have calculated that on the side. So on the side here, negative 1 plus 2 is 1 minus 4. So you could have just written the negative 14 and just show me in the bracket negative 14. So that's okay. So if you're like, I did it on the side and I put my answer, that's fine. So as long as I see the negative 14. Don't go faster than that because then I can't follow, right? But if you put the negative 14 in that bracket instead of the big bracket, that's okay. Right? So don't do fewer steps than that. I can't follow. Okay, then I'm going to simplify a bit. Now, everyone always asks, should I expand and collect it? Will it make your life easier when we have to do the next step here? The next step here is H1 and H2. Does expanding that to a power of 3 make your life easier or worse? I think it makes it worse, right? Because then you're going to have to sub it in 1, 2, 3, 4. Like it's gonna be a lot more work. So what if I just did H as 0.01? That's not bad. 1.01 cubed. Actually, I'm not going to expand it. So it's up to you. You can expand it if you want. You have a bit of choice here. When we get to the calculus, you have to expand it because then we do some other stuff with it or factor it. But in this case, it's up to you because we're going to sub in the decimals. If you're like, you know what, it's worse to sub it in after I've expanded it, I'm going to leave it that way. That's okay. Okay. If it was just a squared, maybe just expand it because it's super fast to expand. The cube is kind of like, I think it's going to be more work. And then when I sub in to calculate it, I think it's more work. So your choice. I'm going to just simplify this part though, right? So I'm going to do this. I'm going to leave this here. I'm like, I don't think I want to expand that. You could expand part of it. I'm just going to leave it. And then this is minus 15 and this becomes minus 14, so plus 14. All over H. And then, again, I'm choosing to not expand it because I think subbing into that, the cube, is actually easier like that. There we go. So that's as far as I'm going to go. Again, your choice if you want to expand more. Just make sure you expand properly if you do. And then we're going to sub in. So H1 and H2. So H1 is going to be negative 0.01. Okay, and then here, H2 is 0.01. Okay, and we're just going to go right ahead and start to calculate. So this will be M equals, and I'll go negative. And again, if you want, you can do 1 plus the negative 0.01 all at once and put 0.99 there, or you can show it. So 1 plus negative 0.01 cubed plus 1 plus, I'm going to run out of room. Negative 0.01 squared minus 1. Or you could have skipped that line and done this. Negative, and this will be 0.99 cubed plus 0.99 squared minus 1. Right? So if you didn't want to write this substitution, you can go right there. So that's probably where I would try to start. A little less than 1, a little more than 1. Okay? I know it's a bit messy there, sorry. Right? And then when I calculate this, again, I do not want to see each line done. Like, I don't want to see 0.99 cubed. So on my calculator, get used to it's negative, and it's 0.99 cubed plus 2.99, I'm punching it right in, squared minus 1. So I get the whole top. Oh, my H, sorry. H is negative 0.01. You plug it into here. Negative 0.01, negative 0.01. So let me just see if I got that right. So this will be negative 0.99 cubed plus 2 times 0.99 squared minus 1